Next, let's discuss troubleshooting NTP, Network Time Protocol. Here's the way you might see it configured. You might have a connection out to the internet and you've got a router connecting out to the internet, and you're going to point out to the internet to get your time. There might be an atomic clock, an NTP server somewhere out on the internet that's going to give time to your router. Your router can then start handing out time to devices inside of your network. It can hand out time to servers, maybe a switch, maybe a router, and by doing this, all of our network devices can agree on what time it is, which is a great thing for troubleshooting. We might be able to do some event correlation. We look at the logs of this router and the logs of this server. We had an issue around 2:15 a.m. yesterday morning. We look at the logs and see that they both reported these oddities at about the same time. Maybe these things are related. We can do some event correlation. But if things are not working as expected, what do you think might be going on? Well, we could have an access control list that's blocking the NTP traffic. It's an easy to remember port number, by the way. It's UDP port number 123. That's an easy one to remember. If we are doing NTP authentication, that's optional, but if you are doing it, you've got to have matching authentication credentials or else you're not going to form that NTP agreement. Also, we've got devices that may be in different time zones. If I'm getting time from an NTP server somewhere around the world, it's in a different time zone than I am. We need to go into our devices and say, I'm in this time zone. And some parts of the country, some parts of the world will adjust based on something like daylight savings time. They will, as we say, spring forward and fall back. Not everybody does that, though. If we do adjust for what some people refer to as daylight savings time, we need to adjust for that. Also, we might just have a situation where our NTP server is not accessible or it's misconfigured, or maybe let's say that for some reason something's happened on this link between our router and the internet, and we've lost synchronization with that internet-based time server. Maybe something is just wrong with our router. The router has some process that's consuming CPU resources. If the router is so busy doing something else with its CPU, it might not have time to do its NTP tasks, and that could cause us to lose some synchronization. Or when you first set this up, this is interesting, let's say that we're setting up this router to sync with this router. We're saying, I want to get my time from this guy, let's call it R1. If their clocks are fairly different at the beginning, this could take a while. NTP does not just say, all right, I'm going to trust you for my time. What's the time? All right, let me set my watch accordingly. No, it's going to make incremental adjustments. If they're very close on time, then just really quick, they'll go adjust, and they match up. But if my authoritative time source is here and my router's clock is way down here, we're way off in terms of time, I'm going to look at that and say, that's a really different time than what I have. I'll make a little adjustment, then I'll make another adjustment. We just sort of, we get closer and closer, and finally we'll synchronize. But it could take it might take 15 minutes if we're very different in our times. Something else to keep in mind is something called a stratum value. The believability of a time source is measured by that time source's stratum value. And if we have some atomic clock out on the internet, that atomic clock might have a stratum value of a 0. That's considered to be the most authoritative source. If there's some cesium clock out there, maybe it's got a stratum level of 0. And if our router learns from that cesium-based time source, we're going to increment that stratum value by 1. If I'm learning from a cesium clock with a stratum level of 0, then I'm going to have a stratum level of 1. And if somebody learns from me, they're going to have a stratum level of 2. And if somebody learns from them, you can guess it, they're going to have a stratum level of 3. Every hop that we get further and further away from 0, we're incrementing by 1, but there's a limit. It kind of reminds me of RIP. Remember with the routing information protocol, we have a limit as to the number of hops that we can propagate and still reach a route. There's a 15 hop limit, 16 is considered unreachable. It's pretty much the same thing here with NTP. We can have a maximum stratum value of 15 and it still be usable. But if I've got a router here and let's say that this guy has a stratum value of 15, if I have another router that tries to learn time that is not going to work because this guy would have a stratum value of 16, and that's not valid. We would not learn time in that case.